Hello everyone, welcome to my YouTube channel. So today we will be learning about the laws of exponents. So the laws of exponents are also known as the rules of exponents or the laws of indices. They are the mathematical rules that simplify expressions involving powers of numbers or variables, and they are very important in solving multiple problems in mathematics. So here are some of the key laws, their equations, their explanations, and some of the examples related to the laws of exponents. So we'll start with the first laws or the first rule, that is the product rule. So in the product rule we have the expression as a to the power m times a to the power n, and what it says is when multiplying two powers with the same base we can add their exponents. So here we have the same base a as the same base, and we have the two different power m and n. So if two powers have the same base, we can simply add their powers, or we can simply write this as a to the power m plus n, since they have the same base a. So for example, we have one example here, 2 to the power 3 times 2 to the power 4. So since they have the same base as 2 here, we can just write 2 and we can simply add their power as 3 plus 4. This is the first rule. And the second rule is the quotient rule. So the quotient rule is almost similar to the product rule, but instead of multiplication sign we have the division sign here. So what it says is when dividing two powers with the same base, we have a to the power m divided by a to the power n. So they have the same base, but we have the division sign. What we can do in this case is we can subtract the exponent in the denominator from the exponent in the numerator. So the denominator has the power n, so we can subtract the exponent of the denominator from the exponent of the numerator, that is a to the power m minus n. So compare the difference between the product rule and the quotient rule here. In the product rule, when we have the product sign, the power gets added, but in the quotient rule, when we have the division sign, the exponents gets subtracted. That's the difference between them. So here is one of the example that says 3 to the power 5 divided by 3 to the power 2. So we can write this as 3 to the power 5 minus 2. The other rule is the power rule. So we have the expression as a to the power m raised to the whole power of n. That is, this is the power rule, and what power rule says is when raising a power to another power. So here a is raised to the power m and it is again raised to the power n. So when raising a power to another power, we can always multiply the exponent, that is a to the power m times n. So when there are multiple powers, it can be any number of powers raised to the powers, we can always multiply those exponent. So a to the power m raised to the power n is equal to a to the power m times n. And here in the example here, 4 to the power 2 again raised to the power 3. So here 2 and 3 are the exponents, so we can write this as 4 to the power 2 times 3. So the other rule is the power of a product rule. So here the expression is a times b raised to the power n. So what power of product rule says is that when a product is raised to a power, product a times b is raised to the power, we can apply the exponent to each factor in the product. So we can write this as a to the power m times b to the power m. So here, since we have the product a times b raised to the same power m, we can simply apply the exponent to each factor present in the product, that is a to the power m times b to the power m. For example, we have 2 times 3 to the power 4. We can write this as 2 to the power 4 times 3 to the power 4. This is simply the power of a product rule. And the other rule is power of a quotient. That is almost similar to the power of a product, but instead of multiplication sign we have division sign here. And what it says is that when a quotient is raised to the power a divided b is raised to the power, we can apply the exponent m to both the numerator and the denominator. That is simply a to the power m divided by b to the power m. This is the same case that we can apply the exponent to both the numerator and the denominator. So for example here 2 divided by 3 raised to the power 4 can be written as 2 to the power 4 divided by 3 to the power 4. We can simply divide the or apply the exponent to both of them. And the other is the zero power. This is one of the simplest and the easiest laws in the laws of indices or the rules of exponents. So here any non-zero number raised to the power of 0 is always equal to 1, no matter what the base is. So when it has the power raised to 0, then it is always equal to 1. For example, 5 to the power 0 is always equal to 1. 5, instead of 5 we can have any number, any variable, anything that is raised to the power 0 is always equal to 1. And the other laws is the negative exponent. And the negative exponent, we have the expression as a to the power minus m. So the negative exponent represents the reciprocal. Reciprocal means 1 divided by reciprocal of the base raised to the positive exponent. Positive exponent, that is we have initially minus a to the power minus m, but when we have the negative exponent, in order to make the base, in order to make the sign of the exponent positive, we can simply do the reciprocal of the given base. That is a to the power minus m can be written as 1 divided by a to the power m. Or for example here 2 to the power minus 3. So the sign of the exponent is negative here. In order to make the sign positive, we can simply write this as 1 divided by 2 to the power 3. So this is the negative exponent. And we have the other rule as the fractional exponent. So the fractional exponent is, the expression is a to the power m divided by n. So if you see here, we have fraction in the exponent. Earlier in all the cases the exponent was a single variable, let's say m or n or something m times n, but in this case we have the fraction in the exponent, and in this case the fractional exponent always indicates a root. So the denominator, we have the two part in a fraction. One is the numerator and the other is the denominator. So the denominator of a fraction represents the root. The denominator of fraction represents the root and the numerator represents a power. So it can be written as, the fractional exponent simply represents the root, so we can simply write it as the root. Let's write it once more. Simply it represents the root and we have the base as a. The denominator goes to the root here and the numerator goes to the power of the base. So a to the power m divided by n can be written as root under n is the it goes to the root and a to the power m. Simply the if we see the example, it will be more clear. 9 to the power 1 divided by 2. Here we can write 9 and 2 goes to the root, that is here, and the 1 goes to the power of 9. So it can be written as square root of 9 to the power 1. So these are simply 8 different rules of exponent that are very essential in solving any kind of problem in maths. Thank you so much.